The spiders are ancient. They appear some 400 million years ago, and now spiders lurk around every corner and have colonized every crevice and every nook. They have adapted to all ecosystems on land. Their next step has been to take over the water, which began some time in the Cretaceous. While not able to live in the open ocean, spiders have adapted to both freshwater environments and marine tidal environments like beaches and tidal pools. They have figured out how to move around in the water, breathe while being flooded, and deal with the extreme osmotic changes. Because of the extreme pressure imposed by the ocean, marine-associated spiders comprise less than 0.3% of spider species worldwide. Marine-associated spiders may live in rocky outcrops, under kelp, buried in sand, housed in abandoned mollusk shells, or occasionally in open water. Some even move in and out with the tide on beaches. Welcome back to the channel, everyone. Please like and subscribe. It helps the channel out a lot. Today I wanted to talk about aquatic spiders, particularly marine spiders, or spiders of the sea. And these shouldn't be confused with sea spiders, which are actually the pycnogonids, chelicerates, which are cousins of actual spiders, sometimes referred to as sea spiders, but they are not what I'm referring to in this case. I'm actually talking about real arachnids, spiders of the sea. And these aren't really sea creatures per se. They're actually kind of associated with the solid land around the water, as well as land that occasionally becomes submerged. As I said in the beginning, the spiders are extremely old. They belong to the group the Chelicerata, which is defined by their mouthparts, which are called chelicerae, and on the spiders, these are the fangs that you all are familiar with. But the Chelicerata colonized land from the oceans very early, around the Cambrian, which is when you have this explosion of life forms on Earth, lots and lots of different groups of life, all originating kind of simultaneously. Shortly after that, the arachnids colonized the land, so this group of chelicerates that we know as the arachnids colonized the land, and that was some 400 million years ago. And then we see the evidence in the fossil record of the spiders radiating on the land, colonizing all of the land-based ecosystems. Sometime around the Cretaceous, about 135 million years ago, the spiders then move back into the water. And this is where we start seeing the radiation of species nowadays, with a large number of families of spiders being represented in the water, but not a lot of species of spiders represented in the water. So out of all of the spiders, it's something like 0.3% of species are actually in the water. But the number of times this has happened, this evolution of moving from land into the water, has happened more than a dozen times. So there are a lot of issues that spiders have to overcome when they want to live in an aquatic environment. These things are like movement, breathing, dealing with the excessive amount of salt, figuring out how to feed on things. And these are all really important in all aquatic environments. But when you're comparing the marine environment to something like to a freshwater environment, there are major challenges with the marine environment, particularly because things tend to be much more severe compared to something like a calm pond or a calm lake. The marine environment has a lot of tidal forces. There's a lot more things living in the ocean. There's a lot more osmotic pressure on these organisms. Movement can be much more difficult, things like that. So there's a lot to overcome for these species that can actually live with the ocean. So the first issue that comes up is movement. And there are a lot of solutions that spiders have figured out to deal with the issues of movement on the water. Many of them can row, They can move their legs in a coordinated rowing fashion. They can walk and run on the surface of the water, taking advantage of the surface tension, like you see here with this little guy. This is the pirate spider, Pirata pyroticus. And they can actually stand on the water. They're light enough to actually stand on the water without breaking surface tension. And additionally, they have a very, very waxy cuticle. So their exoskeleton is coated with wax. And they also have quite a bit of hair on their legs, which helps to kind of disperse their weight and take advantage of that surface tension. And they can move around quite well. Some are capable of submerging themselves intentionally and moving under the water, and they will take a bubble with them to act as a little scuba tank. And additionally, some can skate across the water. And this skating, if you've ever seen it, can look very unnatural and extremely off-putting if you happen to be in the water with them. The next challenge that spiders have when moving into a marine environment is figuring out how to breathe when they're being inundated by water, either intentionally, like if they're diving below the water surface in order to catch a fish or a tadpole or something, or accidentally, like when the tide comes in or you have ocean spray coming in and potentially drowning them. So the first solution that both insects and mites and other arachnids and some spiders have come up with is the plastron, which I've mentioned a couple times in other videos. And this is functionally a bubble that is created around the body of the insect or spider that is then used to breathe off of. And this bubble is maintained by a collection of hydrophobic hairs, which spiders tend to have a lot, as well as a very, very waxy cuticle. So the body, through this wax and through the hairs, are repelling the water from the body, which allows an air bubble to form, and then a spiracle, which is the hole through which arthropods frequently breathe when they don't have gills, can then exchange air with that bubble around the body. The second solution to this problem of breathing is called a diving bell. And this is particularly seen in the species Araneae aquatica, which is one of the only truly aquatic spiders that spends or the majority of its life in the water. And what they do is that they will spin a kind of silken net and they will use it to trap a large bubble, which they then haul around with them underwater. And they can take this with them when they go hunting so that they don't need to resurface for long periods of time. Eventually, this bubble will collapse in on itself from the water pressure, but it helps to be the silk helps to stabilize this bubble for longer periods of time. Another solution to this problem is something that is referred to as a sand burrow, but it doesn't necessarily have to be in sand. Basically, the spider constructs a nest layered with water repellent silk, and then when the tide comes in, they can scurry down into that nest surrounded by this silk bubble, and that silk bubble will repel the water, forming again a bubble of air, which they can then wait out the tide. Another very unique form of getting your air supply when underwater is a form of commensalism with kelp, primarily done by this group of spiders, the Desis spiders. And what they do is they get underneath the holdfasts of kelp, which are kind of like the roots of the kelp, although they don't actually function the same way that plant roots do. Instead, these holdfasts actually secure the kelp to the substrate, the rocky substrate or whatever substrate the kelp happens to be attached to. And there are little gaps within this kelp. The spider gets in there and again spins a silk sort of web or a silk sort of net, which helps to trap the air. Then when the spray and the tide comes in, the kelp becomes submerged, but there is a large pocket of air that the spider can stay in until the tide goes back out. And finally, the last known solution, although there are, I'm sure, many, many more solutions, the last common solution is nesting within old mollusk shells or old barnacle shells, things like that. And it's the same sort of thing where they will spin a silken net in order to trap air. And then when the substrate becomes submerged, they can continue to breathe underwater. A spider like this, a nursery web spinner spider of Dolomedes, the genus Dolomedes, is particularly good at taking advantage of the plastron effect. And that is because they are covered very, very densely with these hairs. And all of these hairs on the body allow for a very, very large air bubble to form around the spider. And so there are multiple species within this genus that do this, and they can live in shallow streams or in a marine environment underwater for up to 20 minutes before they have to resurface to refill the air bubble. And finally, there's one sort of not so great way of dealing with water overtaking you and flooding you out, which is that some spiders will go into a state of immediate dormancy or a hypoxic coma when they are suddenly flooded. And so they literally just shut down their bodies until the water recedes, and then they can go about their day again. The next issue is how to deal with all of the salt in the marine environment. And there are a bunch of theories for how spiders could deal with salt, but there's really only been one demonstrated way, and at least very, very well-known way. And it's by just increasing the salt content of your blood. So some of these marine spiders will greatly increase the salt content of their blood until it is much higher than that of the ocean. And that is how they deal with the issues of severe osmotic pressure regulation. And lastly, what I wanted to talk about were the issues of dealing with feeding in an aquatic environment. And this is primarily due to something that I never really thought about, which is spiders feed by injecting their prey with venom and enzymes in order to break down their internals in order to suck them out. This becomes a big problem when you're inundated with water. One, because it might wash the venom and enzymes out. And two, you have these big fang holes in your prey, which if they are liquefied, it can just pour out into the water. So how do you deal with this? Because something like these, the Dolomedes spiders, they hunt quite a bit. They hunt fish, they hunt tadpoles, they hunt amphipods, or any sorts of things that they can get, because spiders tend to be on the verge of starvation just all the time. They're very ravenous predators. And the solution to this is that you have to get the prey to the surface or to a dry area. So a lot of times with like Dolomedes here, they will hunt on the surface of the water. They might skate out and they'll trap prey that comes too close to the surface and then drag them up and have to hold them above the surface, or they'll have to drag them to a rock or something like that and feed that way, because they can't really feed in the water like you might suspect some other chelicerates and things could. So that's all I really wanted to talk about today. I will link the article that I got a lot of this information from. It's an annual review article about marine spiders. It's extremely interesting. I do encourage you to read it. It's not particularly long, and I'll talk to you guys later. Thanks.